What happens when construction starts at the finish line by mistake? Imagine a massive tunnel project, years in the making. Crews dig, machinery roars, and the city waits eagerly. But there's a twist: the tunnelers realize they've started in the wrong direction. Now, what? Welcome to the world of accidental engineering solutions, where some of the world's greatest infrastructure projects were saved not by perfect planning, but by creative thinking when things went off the rails. Let's kick things off in London, in the 19th century. The Thames Tunnel was meant to be a marvel, burrowing under the river and connecting neighborhoods. But early on, water kept flooding the site. Legend has it, the engineers, Mark and Isambard Kingdom Brunel, were inspired by an accidental discovery. Watching shipworms burrow backward through wood, they designed a tunneling shield that let them dig inch by inch, pressing forward, but always ready to retreat and reinforce. A disaster forced them to rethink, and that backwards logic now influences tunnel boring worldwide. Fast forward to Switzerland, where the Gotthard Base Tunnel, the world's longest railway tunnel, faced a classic mix-up. During excavation, two teams drilled toward each other from opposite ends of a mountain. One group went slightly off course. But instead of starting over, they mapped the mistake, recalculated, and used the error to test new surveying methods. By the time they met in the middle, the margin of error was barely a few centimeters, an unplanned blunder that prompted Swiss engineers to pioneer more precise GPS-guided drilling. Now let's look at New York City. The Holland Tunnel, which links Manhattan to New Jersey, was plagued by a challenge no one anticipated: carbon monoxide buildup inside an enclosed space. When early test runs left crews gasping for air, the solution came, oddly, from a maintenance worker who suggested using ventilation fans in reverse, drawing air out instead of pushing it in. This accidental insight led to the world's first tunnel ventilation system, a model still used today. These aren't just isolated mishaps. In Japan, the Seikan Tunnel, buried deep under the ocean, was constantly plagued by water leaks. At one point, frustrated engineers abandoned the original plan and started working backwards from the finish line, using clues from the water's flow to guide new tunnels that bypassed the worst leaks. What began as a desperate pivot ended up accelerating construction by months. So why do these backwards fixes work? Because when things go wrong, the rules change. Mistakes force engineers to ask different questions, and sometimes, the solutions that emerge are better than anything in the playbook. These accidental successes have shaped how we build, connect, and even how we solve problems far beyond construction. So next time you pass through a tunnel, remember, it might just owe its existence to a lucky mistake and some backwards thinking. Follow Lorelight for more stories worth knowing.